Okay, knowing that the derivative of sine is cosine, let us now then try to find the derivative of cosine. That was sort of the remaining thing to be found, so let's do that. So we want to find the derivative, and like any derivative, we can do this by taking the limit as h approaches 0 of f of x plus h minus f of x over h. That is the definition of the derivative. So in the case where our function is cosine, what is this going to look like? Well, it's going to be a limit as h approaches 0, but f of x plus h is going to be our function with x plus h plugged in. Well, when you plug x plus h into our function, we get cosine x plus h. When you plug x into the function, you get cosine x. This all divided by h. And then you say, okay, man, how are we going to make sense of this? Sort of nodding back to the techniques and tactics that we used with find the derivative of sine. Upstairs, we've got this sum in our angle, and we can apply our angle sum formula. So let's do that. We still have a limit as h approaches 0. I mean, heck, if we tried to plug in h up here, we'd just get 0 over 0. So we know more work is needed. And by applying this old school trig formula, let's see, to cosine x plus h, you get cosine x, cosine h, minus sine x, sine h. We still have the minus cosine x off here to the right, and this is all over h. Okay, how can we make sense of this? Well, note, upstairs, the first and the last terms have a cosine x. So if we factor that out, we'll still have a limit as h approaches 0. But factoring out the cosine x, what's going to be left over? Well, taking the cosine x away from cosine x, cosine h, will leave your cosine h. And taking a cosine x away from cosine x will leave 1. That 1 being subtracted away because we were subtracting away the cosine x. This is all over h because each of these three terms are over h. So this first term, factoring out the cosine, accounts for the first and the last terms of the step previous. We still have to account for the middle term, and with the middle term, I'm going to factor out the minus sine x. So factoring out the minus sine x, we get sine h over h. And so our entire limit boils down to this expression. And then you say, what results from this expression? Well, taking a step back, remembering the limits that we did previously, sort of looking at the numerics and discovering what they are, cosine h minus 1 over h, as h approaches 0, which is the situation here, that is 0. And in fact, then cosine x times 0, that whole term is going to cancel out. Because cosine x is going to be whatever it is. It does not depend on h. So cosine x times 0, that's just 0. What remains over on the right? Well, we have sine h, sine h over h. Here the limit as h approaches 0, precisely the situation we dealt with previously, that approaches 1. So while the first term multiplied by 0 and canceled away completely, this next guy is minus sine x times 1. Well, anything times 1 is just itself. This is minus sine x. So, the long story short, running through the derivative computation for our cosine function gave us the function minus sine of x.